next we will look into another program where it will try to model one digital clock. So, digital clock has to be constructed. So, statement of the problem is like this. So, we have to implement a digital clock. The clock will normally display the time in 24-hour format in HH/mm/ss, okay, hour, minute, second format, and there is a mode button. So, if the mode button is pressed, so it will show the current date in DD/mm/yy format. So, hour, time and date. If the button is released, so it comes back to display the time again. This date and time values, so they will be stored internally at some memory location. 3 bytes will be used to store the date, month and year values. So, DD, mm and YY values, and the values of the memory location similarly for this hour, minute, second also will be 3 more bytes. So, total 6 bytes will be used for storing this HH, mm, SS, DD, mm, YY these values. Okay. And then these locations, the values of these locations will be updated automatically through a periodic timer interrupt. So, 8051 has got the timer interrupt. So, at periodic intervals that interrupt should come and it will be it will update this timing. Okay. And assume that there is a routine display. So, which when called with DPTR pointing to the beginning displays 3 bytes at 6 successive display modules. So, there are 6 display modules are there, maybe 7 segment display or something like that. So, this HH, mm, SS will be displayed. So, these are the 3 successive bytes, it will be they will be displayed on these 6 successive display modules, and if the DPTR points to the location containing this DD, mm, YY, then it will display the date part. Okay. And if it is DPTR points to the hour, minute, second part, then it will be displaying the hour, minute, second. Also, we assume that there is a routine called calendar, which when called updates the date value. So, naturally this calendar routine is also quite complex, where it will be updating the after every second the interrupt will come. So, accordingly this SS, mm, HH they will be updated, and this DD, mm, YY those values will also be updated. So, it is a very complex routine. So, we will not go into that. So, you can write that code separately, but our purpose is to show how this interrupt and these display modules they can be integrated into the system. Finally, the bytes corresponding to the time are stored at location 8000, 8001 and 8002. So, HH is in 8000, mm is in 8001, SS is in 8002, and then the bytes corresponding to the date DD, mm, YY they are at 8003, 4 and 5. So, how to design this particular program? Okay. So, let us see how to do this. So, we assume that the crystal that is connected to the system is say 12 megahertz crystal. For the ease of calculation, so we will take that 11 point something the fractional value of that crystal frequency. So, we will take it as 12 megahertz. So, we will be using this timer 0, we will be using this timer 0 for counting seconds. So, after every second I will be I want to get an interrupt, and then I should be updating the second value. So, we should get a clock frequency of 12 by 12. So, you know that this for the timer. So, the system clock is divided by 12 to get the clock reaching the timer. So, the clock that reaches the timer is 1 megahertz. So, if we set the value of the timer to 3036, set the timer value to 3036 and repeat the timer for 16 times. So, this is the timer value that is set, and repeat timer 16 times. Then you will get about so how much so it is, so every time you set this value, so you get a time value of 65536 minus 3036, okay, this into 16. So, this is the total of after. So, this is part time. So, if you repeat it 16 times, so it is into 16. So, this value is about 10 power 6. Okay. So, which is so this will be this is 10 power 6. So, this will be giving me so it is matching with this 1 megahertz. So, this delay will be matching to that 1 second that we are looking for. Okay. So, for designing the timer part, I have to use this timer with the initial value as 3036, and then repeat the timer 16 times to get 1 second delay. Okay. So, after the timer interrupt has come 16 times, I should update the second field, and then the updation routine will be updating the second field, minute field, etc. The update routine should be called accordingly. So, this is the basic idea that we will be using while writing the program. So, we define one memory location repeat count. So, we initialize define one memory location repeat count db 0. So, what the system will do? It will give you one memory location whose name is repeat count, and it will be initialized to 0. Then org 0 ljmp main. So, it will be jumping to the main routine then from the beginning. Then for the timer interrupt I have to do something. Okay. So, for the timer interrupt, so timer interrupt is from 000b. So, I have to say like org 000b hex, and there I should put the code for the timer interrupt. The first thing that we need to do is to save the DPTR register, because the DPTR value will be used by this timer interrupt. So, this DPTR value will be saved. So, that is done by push 82 hex, this 82 hex and then push 83 hex. So, this 82 hex 83 hex, so they are actually saving the DPL and DPH registers. This if you look into the corresponding address, so this is for DPL and this is for DPH. Okay. Then we have to save the A register, the accumulator register. So, we also save push 0E0 hex. So, this is the saving of A register, and also we will be in our code we will be using the R1 register. So, that R1 register is also saved. So, push 01 hex. So, this is the saving of R1 register. So, these values are saved. So, this is actually the proper way of writing interrupt service routine, because in interrupt service routine, so you may be using some registers. Now, you do not know from which point in the system the interrupt has come. So, that the program that was executing there might be using those registers, fine. So, it is better that whatever register you are going to use in your ISR code, at the beginning you save all those registers in the stack, and before coming back from the subroutine you just restore all those registers, so that the program which got interrupted will be able to continue without any problem. So, this is though in our previous interrupt service routine, so we have not done this thing. So, ideally you should do this for all ISR. The whatever register you are using, you first save those registers into stack, and before coming back, so you restore all those registers from the stack, fine. Then in the R1 register we load the repeat count. So, move R1 comma repeat count. So, that repeat count will be using as a counter for that 16. Then increment R1, and we check whether the value has become 16 or not. So, CJNE R1 comma hash 16 comma L1. So, if the count is not 16, then I do not have to do anything, no updation of time will take place. So, I have to skip over the next part of the code. So, this part of the code will be valid when we will be coming to updating the this part whatever we will be writing now. So, they will become useful when this count value has become 16. So, that the second has to be updated. So, for updating second, what we do? So, first we reset this R1 to 0, move R1 comma hash 0, then move DP from 8002 we are getting the DPT, the value 8002 will be obtained in the DPTR, because 8002 is holding the second value. Okay. So, 8002 is holding the second value. So, move dptr comma hash 8000 to hex. Okay, that so that this is move x, sorry, no, this is not move x, this is move, and then move x a comma at the rate dptr, move x a comma at the rate dptr. That means I am updating the I have got the second value into the a register. Now I increment a, because 1 second has passed. So, I increment a. So, next I have to check, I need to check whether the a value has become 60 or not. So, if it is 60, that means I have to update the minute part. Okay. So, CJNE 60 comma L1. So, if it is less than 60, nothing is done. So, the updation is over. But if it is less, if it is more than, if it is 60, then it will come to this point. I clear A, the accumulator is cleared, and then I need to save this new value of this accumulator into the second location, the location corresponding to the second part. So, move x at the rate dptr comma a, so it will put 0 onto the second part. Then I have to look into the minute part. So, for getting the minute part, I have to move a comma, sorry, this is not a, move dptr comma hash 8001 hex, fine, and then I should get. So, this now if I do a move x a comma at the rate dptr. So, I will get the minute part into the accumulator, and since there is the value, the second was over. So, that 60 was over. So, I need to increment the minute part. So, accumulator is incremented. Now, again I need to check whether this value has become 60 or not. So, if it has become 60, then the hour value has to be updated, otherwise this is fine. So, again we compare CJNE a comma hash 60 with then if it is not 60, then nothing needs to be done, but if it is equal to 60, then I have to clear a, then store this pattern onto the memory location for this minute, and then I have to do the update. So, that is I need to do a move x this at the rate dptr comma a, fine. Then I have to update the day the hour part. So, hour part is available in location to 8000 hex. So, move dptr comma hash 8000 hex, fine. Then move x a comma at the rate dptr. So, this will take the hour part into a register, and now I need to increment a. So, if I do an increment a, that means the a value will be updated. So, this hour part is updated. So, now I need to check whether the hour part has become 24 or not. So, that CJNE a comma hash 24 comma L1. If it has become equal to 24, in that case I need to clear the accumulator and move this 0 value to the hour memory location. So, that will be done using this move x instruction, move x at the rate dptr comma a. So, that register is cleared, and also that location is cleared. Now, I have to update the calendar. So, I said that there is a routine called calendar which is which will be able to do that. So, we are not writing that routine. So, we are giving a call to the calendar routine for doing that. So, a call calendar will call that routine and it will be updating the calendar part. Okay. So, done. Now, the other, now that L1 onwards, okay, that L1 onwards, that portion has to be written where I do not need to do anything. So, there actually the value is the value, the second value or the minute value or hour value is, so updation has been over. So, I do not need to do anything. So, what I do? So, move x at the rate dptr comma a. Okay. So, like, so a register was holding the hour value or minute value or second value, the updated part, and that is moved to the dptr. Okay. And this repeat count should this R1 has been implemented to hold the repeat count. So, that has to be restored. So, we move this R1 to the repeat count memory location. So, move repeat count comma R1. So, R1's value will be moved to the repeat count memory location. Then I am done. So, I have to now I have to restore all those registers. So, it should be in the reverse order in which we have saved them, like pop 01 hex, then I have to pop 0 the accumulator register, pop 0 E0 hex, then that 83 hex, pop 83 hex, then pop 82 hex. Okay. So, those locations are popped out. Now, this TL and TH, so they are to be again loaded with the values. So, now actually, so this part where I have to again load that that pattern, that 30 that 3603 or that value 3036, that value 3036 has to be loaded into this the timer registers TL0 and TH0. So, that has to be done. So, we do it like this, that move TL0 comma hash 0 DC hex and this TH0, move TH0 comma hash 0 B hex. So, if you do that, so this number 0 B DC, this is actually that 3036 hex, 3036 value, and then I have to set the timer, set B TR0, so that the next the timer is enabled, so that it will again be interrupting the system when the timeout occurs. So, this is the end of the interrupt service routine. Now, the main routine that I need to write. So, the main routine will be something like this. First, this timer has to be programmed, the mode has to be set. So, we have to move it, the tmod register has to be programmed with the pattern 0000 0001 in binary. Then TL and TH, they are to be having that this time values, the count, the initial values. Move TL comma hash 0 DC hex, then move TH0 comma hash 0 B hex. Then I have to clear the TF0 bit, and then I have to enable the interrupt for the timer. So, you can check that this interrupt setting will lead to the value 82 hex. Okay. For enabling this timer 0 interrupt, it will be 82 hex. Then this will be set B, this is set B TR0. Okay. This is this set B TR0. So, the timer will be enabled, and then I can just wait here till the. So, this is we can wait for this it said that now I have to read the mode button is pressed or not. So, that has to be checked. So, jump on bit P 1.0 comma L 2. Okay. Then if it is, if the mode button is not pressed, then this bit is 0. So, we should display the date part. So, in that case the DPTR register should be loaded with the value 8000, it should be loaded with the value 8000, and then I can just jump over to L 3. Then in L 2 we came because the mode button has been pressed, fine. So, this DPTR has to be loaded with a different value. So, move DPTR with the address of this date part, okay, that is 8003 hex. And then in L 3 I have to call the display routine, a call display, and then SJMP L 4. So, this is the main routine. So, main routine, what are you doing? First setting the timer mode, setting the time count, clearing the timer interrupt flag TF0, then we are enabling the interrupt, okay, the timer interrupt is enabled, then we are starting the timer. This much is done. Now, we are so this is done only once, up to this setting is done only once. Now, I am reading port 1's bit number 0, and if that bit is set, that is the mode button. So, if the mode button is pressed, then this bit is 1. So, we are coming to L 2, and in the DPTR we are putting the address of the date, and the display routine is called. So, display routine will display the value of the 6 we have got 6 displays, and they are that HA, the DD, MM, YY, those will be displayed. And then SJMP L 4, so it will again go back there, check whether the mode button is pressed or not. So, if the mode button is not pressed, in that case it will display the time part. So, it will come to 8000 hex. So, 8000 hex will go to DPTR, and then this the value. So, it will be jumping to L 3, and there it will be displaying part. So, and since DPTR points to the day part, the hour, the time part. So, it will be displaying the time part properly. So, this way I can do this thing. So, only one thing, one small thing is missing. So, at this point I think we need to have another clearing of this TF0 bit, otherwise it will be taken as another interrupt immediately. So, that clear TF0. So, this line should be there. So, in this way we can design a timer based routine that can be used for designing a digital clock. Okay. Next, we will look into another program. So, suppose that as we have got an oscillator connected to that 8051 that is operating at 12 megahertz, and we want to generate a 4 kilohertz square wave on the pin 1.4, okay, using this timer 0. So, how to do this? So, for this matter again, so we have, so the timer clock this timer clock that we have is is a 12 by 12. So, it is 12 megahertz crystal divided by 12. So, the timer clock is 1 megahertz, but the waveform that we generate for 4 kilohertz. Okay. So, the required time period for this clock signal, time period needed is 1 upon 4 kilohertz. So, that is about 250 microsecond. So, this is 250 microsecond that we want. So, since it is a if we assume that it is a 50% duty cycle square wave. So, on period is on period and off period. So, both of them are same, and they are going to be equal to, on period and off period are same, and they are going to be equal to 125 microsecond. So, what we need to do from the timer is that we need to have a delay of 125 microsecond. So, for getting that, so I have to see what is the value that should be loaded. Okay. So, the value to be loaded is equal to 65536 minus this 125 by 1. Okay. So, 125 microsecond, and this is 1 megahertz. So, I can divide it by that. So, this quantity So, it is basically 65411 in decimal. So, that converts to C1FF in the hexadecimal notation. So, this should be the value to be loaded, and accordingly we can have this square wave generated. So, we will write that program. So, how to write it? So, we can we again take help of the timer interrupt ORG 0000 hex you can write, then LJMP main. So, which will take this assembler this program to the at location memory location 0, it will put the instruction LJMP main. Then the timer interrupt is at location 000B. So, ORG 000B hex. So, that is the timer location, and the timer routine is simple. So, it just complements the bit P 1.4. When the timer interrupt comes, the action that I need to take is just complement the port bit 1.4, and then the timer has to be restarted. So, for that purpose, so I have to move this TL0 comma hash 0 FFX, and I have to move TH0 comma hash 0 C1 hex, and then if that interrupt comes, then I need to clear TF0. We have to clear this TF0, and we have to set B TR0. Okay. Then let I. So, this clear bit will be clearing the bit, so that it is not the interrupt has been serviced. So, it should be cleared, otherwise it will be taken as another interrupt, and this set B TR0. So, it will be setting the timer, so that it will be the timer will start again. So, that interrupt can come. Then maybe my main program is from location 8000 hex. So, I put another ORG here. So, ORG 8000 hex, and the main program is starting from there. So, here the thing that I need to do is initialize the tmod register. So, I can say like move tmod comma based on the requirement hash 00000001 B, then move TL0 comma hash 0 FFX, then move TH0 comma hash 0 C1 hex, and then clear the TF0 bit, set the interrupt enable register for getting the interrupts hash 82 hex. So, this will enable the timer interrupt 0, and then I have to start the timer. So, that is by set B TR0, and now the main program can wait in a loop, because there is nothing more to do. So, it is SJMP L1. So, it will be looping there. So, now so what the main program is doing, it is setting the timers, setting interrupt and all that, and then it is looping in an infinite loop, sitting idle actually, and whenever the interrupt comes, the timer interrupt comes. So, it will be coming to this location 000B, and if you look into this memory layout for this program that I have written, so it is like this. So, at location 0 we have the instruction LJMP main, and main is 8000. So, it has got this one LJMP main. So, that is 8000, and then at so this is there. Then at 000B, at location B, you have got this code, this interrupt service routine code. So, this will be here, fine. Then at 8000, from location 8000, you will have this piece of code. So, if this is this piece of code will be loaded here. Now, how the system executes the whole thing, like when the processor is reset, the program counter is loaded with 0000 hex. So, it will come to this particular location, it will get this instruction LJMP 8000. So, it will jump to this location 8000, start executing these instructions. So, when it starts executing these instructions, so it is the timer is set and all those things. So, that is done. Then the program is looping at this point. In between, sometime the timer interrupt will come, timer 0 will overflow, timer interrupt will come. So, and the processor it will automatically, the hardware will automatically put the program counter to come to this 000B when the interrupt occurs, and then it will execute this interrupt service routine. And after executing this interrupt service routine, it will again come back to this end point where it was SJMP L1. So, it will be coming back to this point, it will be executing there, it will be looping there continually, it will be executing there. So, this again when the interrupt comes, again this program will be invoked and it will be this interrupt service routine will be invoked and it will go like this. So, in this way we can use these interrupt service routines for doing many important jobs, so which are to be done irrespective of the main functionality that we have in the system. Okay. So, that is for timer 0. So, we have also seen for the serial transmission, we have also seen for this external interrupts. So, this that way interrupt programming is very important if you are trying to design an embedded system where you have got a number of devices or number of activities to be carried on at some specific intervals of time.